Good everyone. Today we're going to be looking at indicial equations. We are still solving problems that involve indices. Remember we said indices is the plural word called index, which means exponent or power. So today we're going to be looking at equations that have indices problem. Indicial equation is the type of equation that involve indices problems. Now remember, equation means an expression that is having an equal to sign. So when an expression is having an equal to sign, we'll be calling that expression equation. Now, indicial equation means an equation that has expression that are in form of indices, in which the unknown will be the power. That is the major thing we're looking at in this fix. The unknown will be the power. So how do we solve these problems? That's what we're going to look at now. We have question 1 to question 5. So you see question 1 and 5 are not actually the same thing. So move from the simpler to the what? The more complex and complex one. This is how we'll be going. Before you know it, we'll be solving other complex problems. So the first thing you have to do for me is to ensure you have subscribed to this channel. Just click on that subscription button because it is very, very important and necessary. Subscription is free, and if you know you cannot subscribe based on the fact that you are not registered or you are not a registered member of YouTube, just register with a valid email. We don't take anything from you, and it's not going to cost you any money. What you have to do is just register with a valid email, then go back and subscribe. Because as our subscription is increasing, we have the full or the energy to do more videos. So let's go to what we have for today. Now the first question we are having here is the model. That is the first thing. You have to look at the model so that you know what you are doing actually. How do we solve indicial equation? Now the model we follow is this one, that if a raised to power x is equal to a raised to power n. Remember we said if a raised to power m times a raised to power n, what are we going to have then? We will have a raised to power m times a raised to power n will be a raised to power n plus n. That's what we are doing. We are doing something that will have equal to sign. Check all the questions, they have equal to sign. That's what we call the indicial equation. It's a form of power or exponents, problem that have exponents or powers, and they also have an equal to sign, in which the power is an unknown number or is a variable. So what I'm going to do here now, they are telling us if a raised to power x is equal to a raised to power n. Now, what is the meaning of this? It means that if you discover that you have two things and they are equal to each other, and their base are the two bases are the same. 2, not 3. That is very important. You know that we have full expression which is 1, another full expression which is also 1. And the two bases of that expression are the same. What you have to do is to cancel out or ignore. You will ignore the base and equate their power. What did I say? If the two bases are the same, you ignore the base and equate the power. So I'm going to ignore these two bases. Then I'm going to say this power here is equal to this power here. So I'm going to have s is equal to what? N. If and only if the bases are the same. So let's solve for x in all these problems we are having now using this model or this rule. The first one I have is that if 2 raised to power x is equal to 8, what will be x? Now the first thing to do is to first of all check or try your best or try your anything you can do to ensure that the two bases are the same. You ensure that this base here and the other base there are the same thing. Now let's check. What is this base? Remember I explained base in our first class. You have like let's say a raised to power m. This one is called power. Then this one is called the base. Remember that the downside is the base, the upper side is the power. That's what we call it. So this one now, this is the base, this is the power, this is the base, and the power of this one is 1. If there's no power, you assume the power to be 1. That's how we run mathematics. So you check. This base and this base, are they the same thing? No. This one is 2, but this one is 8. So what are we now going to do? That is where the mathematics comes in. Now, if the two bases are not the same, then you try to make sure the two bases are the same. That's what you do. You You try your best. See what you can do to ensure. Don't do manipulations. Don't do anything that is not mathematically oriented or don't follow the rules of mathematics. You try your best using the valid rules of mathematics to ensure that the two bases are the same. So what do we do here now? We check. That's a solution. We have 2 raised to power x. That's what we're having. Then we now check. Okay, can we raise 2 to any power at all? And the answer will be 8. Yes. What can we raise 2 to that will give us 8? If I raise 2 to the power of 3, the answer will be 8. Let's check. 2 raised to power 3, that's 2 times 2 times 2. Let's check. 2 times 2 times 2 means 2 raised to power 1, 2, 3. 2 raised to power 3. That's what it means. So 2 times 2, 4. 4 times 2, 8. So it's 8 as 8. So 2 raised to power 3 means 8. So you have to use 8 now. Since we want the two bases to be the same, you ensure that you now raise 2 to a power to give us that 8. So the next thing we do, you will not ignore this base, they are the same, and you now equate the power. Our s will be equal to 3. Simple as simplicity. That's how to solve that. I hope that is clear. Yes. So let's move to the next question. Let's move to the next question. The next question is if 7 raised to power x equals to 49, what will be x? The two bases are they the same? No. How can we make the two bases to be the same? We have 7, the lesser base. That is the first thing we work with. We work with lesser base. We have 7 raised to power x here. Then 7 for the numerator is lesser, 7. So now check. Can I raise 7 to the power of 49? Yes. 7 raised to power 2 will give us 49. 7 times 7 will be equal to 49. So next thing you ignore the bases that are the same and equate their power. Then this one will be equal to this. Just as this one was equal to that power there. So that's what we're going to have there. Then s will be equal to 2. Then let's move to the next one. We're already going. Ensure you follow us as we follow mathematics. You see, we are not manipulating anything. We are not doing, or we are not following math. Ensure everything we are doing is the same thing. So let's go. Between this base here and this other base, we have 2 here. We have 4, which is lesser 2. So we are going to work with 2. We have 2 raised to power x plus 1 is equals to. Then what I'm going to raise 2 to that will give us 4. 2 raised to power 2 will be equal to 4. 2 raised to power 2 will be equal to 4. So we are still going. You will not ignore the base and you equate the power. Now x plus 1 is equals to 2. That's what I'm going to have. S plus 1 will be equal to 2. So that's the next thing I'm going to do here. Now let's shift this question downward. 3 raised to power x plus 1 is equals to 9 raised to power 2x plus 3. Let's shift downward so that we'll have space to finish this our question. So we're going to be having. Now, this what you have here is not the final answer to any problem because the s is not completely defined there. So that's not an answer to the problem. We still have s plus 1 is equal to 2. So that's called simple equation. That's what we call it. It's called what? A simple equation. A simple equation is a type of equation is a type of polynomial equation whose degree is equal to 1. That's what we call a simple equation. Any equation you see, then you have s to the power 1 or y to the power 1 and so on. And it should be just one unknown that is inside. So that if you have s plus 3 equal to this and you are saying so for x, and s is not carrying power higher or greater than 1, we call it a simple equation. Actually, if you know that the equation is simple, that is just a name. Just call it a simple equation. And how do you solve simple equation? You first you collect like terms. Now when you don't collect like terms, you move unknown to one side, you move the known to the other side. So what is the unknown here? X. X is unknown, you go to one side. Then what is the known? The known will move to the other side. And if any number crosses this equal to sign, it will change sign. Which sign are we talking about? We have positive sign, we have negative sign. If positive crosses this sign, it will change to negative. If negative crosses this sign, it will change to positive. That's what I'm trying to say, change to positive. So now let's say 1 does not have x. So 1 is going to go to the other side because we are collecting our like terms. So only x is here. Then if plus 1 crosses this sign, we change to minus 1. We already have 2 there. Then this one will now move to the other side. This plus crosses this equal to sign, changes to what? Minus 1. Then x will now be equal to 2 minus 1. What is that one? 1. So that will be the answer. So actually, the answer is that s should be equal to 1. Then let's go to this one. So what we are going to have. we have 3 raised to the power x plus 1 is equal to 9 raised to the power 2x plus 3. That's the question. So what are we going to do there? Or what can we do in that place? What can we do in that place? So let's check. Between 3 and 9, which one is lesser? Which is lesser? 3. So let us check. And we now check, okay, is there anything I will raise 3 to that will give me 9? Yes. 3 raised to the power 2 give me 9. So I'm going to go. So I'm going to have 3 raised to the power x plus 1 is equals to, now, what am I going to raise 3 to that will give me 9? 3 raised to the power 2 will give me 9 first. So 9 means 3 raised to the power 2. Then this 9 is now raised to the power 2x plus 3. They are already going. So ensure you stay with us. Just stay with us. Then let's go. Let's go. Then we have the next thing we have 3 raised to the power x plus 1 is now equal to 3 raised to the power x plus 1 is now equal to. Now, how are we going to express this? We have 2 powers. We have double power. 2 and 2x plus 3. Remember, I said if you have a raised to the power n and everything is not raised to the power n, how do you express it? It will be a raised to the power n times n in our first class. So if you know you have not looked at our first class on indices, ensure you go back to that class. Go back to that class, check the rules of indices. They are very, very important. Ensure you go back to that class. It's in the channel, just go back to that class and look at it. Then we are still moving. So if you have 2 powers, what you do? Double power, the rules of double power, you multiply the 2 powers. So we have 2 powers here, these 2 and these 2x plus 3. We are going to multiply the 2. So if I multiply these 2 times this, the 2 will affect both numbers right there. So 2 times 2x. What I'm going to have? I'm going to have 4x. That's what I'm going to have. Then 2 times 3, I'm going to have plus 6. So 2 times 3 will give me 6. The next thing we do, you will not ignore the base because they are not the same thing. We ignore the 2 bases. You don't cancel them. And I'm not saying this one cancel this. So no, I'm not saying they are cancelling each other. What I'm saying is that you will ignore them. And you will ignore them. Since they are the same, you don't ignore them and equate the power. And equate the power now have x plus 1 is equal to 4x plus 6. That's what I'm going to have. You will ignore the base and what? And do what? And equate the power. Not you will cancel out the base. The base cannot cancel out. What you do is to ignore it. As if it does not exist, then you equate the powers. So the next thing, after you have equated the power, then you are going to have a polynomial equation that can either be a quadratic equation or a simple equation or other cubic equations. Now, it is a simple equation if the x is not carrying any power at all. Now let's check. This x, is it carrying any power? No. This x, is it carrying any power? No. It's a simple equation. So the x unknown number there, or the unknown, if the unknown is not carrying any power greater than 1, it's called a simple equation. And solve it using simple equations. So what do you do there? To solve a simple equation, the first thing we do is to do what? We connect like terms. Why not connect like terms? Move anything that have unknown to one side, move the one that have unknown to the other side. That's what you do. So let's go. This one is an unknown number, we have x. Let's say we have 4x. It's also unknown, but it's plus. So any number that don't have sign is positive. Like any number that is standing, like this 4 now, is plus 4. If any number that don't have sign, it is positive. Please take note of that. It's still very, very important. So if you don't have 4x here, if there's no sign, it's still positive. And if positive this sign, we change to minus 4x. Now minus 4x is now equal to plus 6. You see, I will remove the sign. If it's plus, we don't write it sometimes, there's no problem. Then, if this plus 1 comes to this sign, we change to minus 1. Then we are going to be happy. Now we have 1s here, but we don't put it. If you discover that it's like a variable don't have a coefficient, there's a 1 there that is not always shown. There's no 1. Now let me tell you something. Let me give you guys a check. If you have a, this a is having a power equal to 1, it's having a coefficient equal to 1, and it's having a denominator equal to 1. But we don't show them. They are called forces not seen or not shown. We only bring them into something like consideration if we now need them. So, if I want to write it now, I will need to put this one. I will put this one. I will write it like this. And that's what I'm trying to say. So, this S, there is 1 here that is not always shown. If it is just 1, we remove it. So, if I answer, okay, I'm going to remove 4 from 1. Look at it. I'm now going to have 1 minus 4 I'm removing a very big number from a smaller number. The answer will be negative. Look at it. If I have 4 minus 1, that's what will be 3. But if I now remove 4 from 1, that is 1 minus 4, the thing will now be minus 3. Look at how we do that side. Let's say you have 4, you borrow 1. How much are you now going? How much are you now having? You'll be having 3. Or you have 4, you're going to give somebody 1. We were having 14 before. You give somebody 1. How many will now be holding what? You'll be holding 3. But this one now, you have 1. You want to go and borrow 4. Or you have 1, you want to give 4 out. Then you have to go and borrow 3 before you can do what you want to do. That's how the thing is. Borrow means minus. Have means plus. That's how the thing is. Love you are. Okay, let me do that to that side so that we don't start cracking some jokes. So that if you are removing a bigger number from a smaller number, the answer will be negative. If you are removing a smaller number from a bigger number, it will be positive. The answers are all the same in magnitude, but I'll put this aside. 4 minus 1, 3. 1 minus 4 now will not be minus 3 because 4 is greater than 1. Let's take note of that. So the same thing. 1 minus 4 will give us minus 3x. You call the x to it. So we have 1x minus 4x will give us minus 3x. S will still be there. S is going nowhere. The next equal to 6 minus 1 will give us 5. The next thing you do, what are we looking for? We are looking for s. And what is the number standing close to that s? What is the number standing close to that s? Now we have a number there which is minus 3 standing close to the x. So the next thing you do, you will divide both sides by that number which is minus 3. Divide both sides by this minus 3. So this one will cancel this. S will be left out. And the next thing, now you cannot put negative number in the denominator of a fraction. So we bring this negative out. We have 5 over 3. That's what we are going to have. Now this is even something like a improper fraction because what we have here is one number carrying a big number. So you can dish everything down to a mixed fraction, which we check how many times can 3 go to 5. 3 can go to 5, 1 times now, I have one number, then you know, I will let 2 will let out over 3. Now 3 times 1, that is 3 plus 2 again, that is 5. This is what you're going to have. You want to put it in terms of mixed fraction. But so maybe in CBE exam or CBT exam, or if you're writing or you can also leave the answer like this. Or supposing I will leave the answer in decimal point. The book can also leave the answer in decimal point, but it's negative. Take note of that, it's very important. Now this one we're having over 5 is 4 raised to the power 2x plus 3 is equals to 8 raised to the power. It's equals to 8 raised to the power 2 plus x. That's what we're having here. This is about 2 plus x. That is the next question. So let's look at that and see what we're going to have. So the same way. But now the problem is, let's have a check. If you check this thing very well, you see this thing very well. What between 4, the 2 bases, check the 2 bases. Which one is lesser? 4. I mean yes. And you now check, okay, is there anything I will raise 4 to that will give me this 8? That is there. Let's check. 4 raised to the power 1, 4. 4 raised to the power 2, 16. Wow, we don't jump. You have jumped through that 8. So there's no a very good number or a whole number to raise 4 to, and the answer will be 8. So we cannot use 4 here. It's not going to work. This one will not work. So what am I going to do? You now check, okay, since that is not working, let's check. Is there any single number or is there any particular number you will raise to a power that will give you 4 and 8 at the same time? Yes, there's a number like that. And which number? 2. 2 raised to the power 2. He said that's 4. 2 raised to the power 8. 2 raised to the power 3. He said he has 8. Same thing as 8. You have done it before now. 2 raised to the power 2 means 4. 2 raised to the power 3 means 8. You have done it before. So instead of us to be disturbing ourselves, if we still use this one as 4, we use this one as 8, the 2 bases will still be the same. So instead of us to be using the cracking our head, let's just call this one 2 raised to the power 2. Since we just want to do to ensure that the 2 bases are the same, then 2x plus 3. Then we call this one 2 raised to the power 3. Then 2 plus x. I don't know if you know what we're doing. what I think is, we want to ensure the two bases are the same. You cannot respond to a single or a whole number that will give us 8. They will look for a number that will raise to the power that will give both 4 and 8, which is 2. So the two bases are still the same thing. The next thing, open the bracket, that is what we do. Open the bracket, so we're going to have 2 raised to power. Now 2 times 2 is that one. We are going to have 4x plus 2 times 3, what are we going to have 6 equal to 2 raised to power. 3 times 2, we have 6. 3 times x, we have what? 3x. That's the next thing. Then, what you do, you will now ignore. You see the bases are the same, you will ignore the bases. You now ignore those 2 bases and equate the power, equate the 2 power. Now, 4x plus 6 is now equal to 6 plus 3x. 4x plus 6 is now equal to 6 plus 3x. Then the next thing, collect your item. Collect your items. We have 4s. Is there anything I have here? We have plus 3x. Now, if plus 1 is equal to minus 3x, then equal to, we have 6. Yeah? Then if this one is sign, we go to change to minus 6 as well. We change to minus 6 as well. Then the next thing, we're going to have 4x minus 3x, that will be x. 4 minus 3 is 1. So if it's 1, we don't put it, we leave it. Then 6 minus 6 give us what? 0. So actually, in this problem, our s is equal to 0. Our s equals to what? Our s equals to 0. For this to be true, s must be equal to 0. Please take note of that. Take note of that. It's very important. So we are still on. I see these indices. So you practice these problems. Ensure you are already good to go. If you don't understand anything you don't understand, you can put it in our comment section. How you are free to rewatch the videos. You know what I'm trying to like. The video is still there, so don't leave that, leave this place. It's YouTube, and please ensure you are following us by subscription. It's not going to cost you anything. Just click on that subscription button and you are already following us. That is, you are supporting this channel, and God bless you as you do so. So I'll see you guys in our next class, and we'll be looking at more problems or more further problems that involve indices. You see, I have a lot of people to solve these indices, but we're going to round up this class here. We're going to hold this class in this place, and see you guys in our next class. God bless you. Thank you.